Hello there, and welcome. Tonight, we're going to explore a kind of intelligence that doesn't look like our own, but is all around us. The animal world is not just instinct and reaction. It's memory, emotion, deception, problem-solving, a crow that remembers your face for years, an octopus that plans its escape with tools, a parrot that asks the right questions, not just repeats them. Beneath fur, feathers, and scales lies a vast, quiet intelligence, ancient, alien, and astonishing. It's not just how animals survive, it's how they think. And once you begin to notice, you can't unsee it. You start to wonder who else is watching you, and what they might already know. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or pressed the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. In the silence of the forest, a raven tilts its head and stares. It doesn't speak, not in the way we do, but something is happening behind those dark eyes. Earlier that morning, it hid a piece of food beneath a rock, careful to look around first. No one was watching, or so it thought. Hours later, it returns to find its treasure gone. And just like that, the bird begins to change its behavior. It hides its next meal more carefully, in multiple places, and even pretends to cache food while keeping the real one tucked beneath its wing. It remembers. It learns. It anticipates the thoughts of others, all without uttering a single word. For a long time, scientists believed that thought and language were twins. One could not truly exist without the other. If animals didn't speak, then they couldn't think, at least not in the complex, layered way we do. But then came the puzzles, the behaviors that didn't fit. Octopuses planning escape routes, rats making decisions under pressure, elephants recognizing what's missing, not just what's there. One by one, these quiet minds challenged the idea that words were required for thought. Imagine a chimpanzee in a lab, staring at a screen. A series of numbers flash briefly 1 through 9 and disappear in a blink. The chimp must tap where they were, in order, on a blank screen. Not only does it succeed, it does it faster than most humans can. This isn't guessing. It's memory, working in patterns in space, in silence. In a coral reef, a cuttlefish hovers with eerie stillness. It changes its color to match a rock, flattens itself to look less like prey, and waits. A shrimp wanders too close. The cuttlefish lunges, tentacles shooting forward like a spring-loaded trap. But this strike wasn't reflex. The cuttlefish observed, disguised itself, and timed its move. It understood, in some way, that waiting worked better than chasing, that patience is sometimes the best strategy. These are not simple machines reacting to stimuli. These are minds solving problems. Minds that don't need speech to hold a plan in place. A squirrel gathers nuts before winter, burying them in scattered caches it will return to months later. Each cache is mapped in memory, hidden beneath layers of snow and time. If another squirrel watches, the first might dig a false hole, just an empty spot to throw off the thief. It knows deception. It tracks who was watching. It remembers where and when and why. In Kenya, elephants walk through the savannah, stopping where a member of their herd once died. They touch the bones with their trunks. They pause longer at skulls than at other bones, longer at elephant bones than those of other species. There is no spoken story passed down through language, but something remains, a sense of recognition, perhaps even mourning. There is a common thread in these moments, a kind of internal narrative, a raven that recalls a theft and adjusts its actions, a squirrel that imagines another's thoughts, an elephant that stops, silently, at a grave. These are not coincidences or instincts alone. They are windows into minds that build stories, not with words, but with structure, with memory, with imagination. Even bees, with their tiny brains, can count. In one experiment, researchers trained bees to fly past colored landmarks to find nectar. When the flowers were moved, the bees still stopped at the correct number of landmarks, expecting a reward. Somehow, in their simple circuitry, a pattern of first, second, third, had taken shape. They had counted. They had planned. And then there are cleaner wrasses, small reef fish that feed by picking parasites off other fish. They remember clients. They change their behavior depending on who's watching. If a potential partner observes them cheating, biting instead of cleaning, they behave better, as if reputation matters. Not only is there memory, but social calculation, the kind that keeps societies stable, the kind that works even when there are no words. We tend to think of thinking as talking to ourselves, a voice inside, narrating, naming, interpreting. But much of human thought, our own thought, is also wordless. The flash of recognition, the gut feeling, the grasp of a complex idea all at once without needing to put it into a sentence. We experience it every day. And so do they. An orangutan builds a bed high in the treetops each night, weaving branches together to support its weight, tucking in leaves for warmth. No one teaches them, yet the beds are consistent, intentional, and well-engineered. A quiet inheritance of skill passed not through lecture, but imitation and observation. Each motion is guided by thought. The design exists in the mind long before the branches are in place. There are parrots that solve locks with a kind of mechanical insight, pigs that remember locations better than dogs. Even chickens, often dismissed as simple, can recognize over 100 individual faces, both human and avian, and remember them for months. Their world is mapped in identities and relationships, held together without language, but not without understanding. And deep in the ocean, there are creatures we barely understand at all. Cephalopods, octopuses, squid, and cuttlefish, whose brains evolved along an entirely different path. Their arms can act semi-independently. Their skin can read light. Their memories form quickly. Their behaviors shift across time and circumstance. They are intelligent, but in a way that doesn't mirror us, which makes them all the more mysterious. I don't know exactly what a raven thinks when it revisits a stolen cache, or what an elephant remembers when it pauses by a skull. But what's becoming clear is that thought, real, dynamic, adaptable thought, does not belong to humans alone. It never did. It comes in many forms, some with voices, others with silence, all carried quietly behind eyes that see more than we've allowed ourselves to imagine. In the end, language is only one way to shape a mind, not the only way. And across the planet, from trees to tide pools, animals are thinking, right now, not speaking, but still undeniably thinking. High above the forest floor, a New Caledonian crow grips a twig between its claws. With slow, careful movements, it shapes the stick into a hook. It isn't copying. It isn't mimicking something it saw another crow do. It's solving a problem. There's a bit of food hidden in a narrow crevice, just beyond reach. The crow lowers its head, angles the tool, and snags the prize. It worked the problem backward, imagined the shape, the solution required, and created something new. The tool didn't just come from instinct, it came from insight. For a long time, we believed animals only solved problems by trial and error, that they stumbled on answers by accident, with no understanding of the cause and effect behind them. But time and observation have revealed something different, a quiet intelligence that doesn't guess, but reasons, that doesn't simply react, but reflects. In an experiment with ravens, researchers placed a platform of food inside a cage, out of reach. A string dangled from the ceiling, attached to the treat. The ravens looked at it, considered the setup, and then did something remarkable. They pulled the string up with their beaks, pinned each loop with their claw, and repeated the process until the food reached them. They had never seen this task before, and yet they solved it. Not through random pecks, but through method, through logic, through a mental model that predicted what might happen next. In the deserts of Namibia, elephants have been observed plugging watering holes with balls of chewed bark to save the water for later. They return hours or days later, remove the plug, and drink. They understand not only the value of the resource, but the cause and effect relationship between their action and its preservation. They think ahead. They store knowledge. They manipulate their environment to achieve long-term goals. A chimpanzee in a sanctuary is given a puzzle box with a treat inside. It's layered with latches, hidden slides, and rotating blocks. The chimp studies it, tests a part, steps away, then returns with a stick it had set aside earlier. It tries again. The movements aren't frantic, they're strategic. When one approach fails, it doesn't repeat the error endlessly. It shifts strategies, reevaluates the box. It keeps track of steps already taken. These are not mechanical responses. They are acts of problem solving, carried out with patience and purpose. Octopuses, too, have demonstrated an eerie kind of cleverness. In labs, they've unscrewed jars to retrieve food inside, not just once, but over and over again, even when the jars are presented with different lids. Some have crawled out of tanks at night to raid neighboring aquariums, returning before anyone notices. One even learned to squirt water at a light switch to turn it off when it bothered them. These creatures, with their alien anatomy and short lifespans, seem to possess a burst of intelligence, like a match struck in the dark. And while their brains are structured nothing like ours, their behavior echoes something deeply familiar: the desire to solve, to outwit, to change the odds in their favor. In coastal regions, sea otters use rocks as hammers, placing abalone on their chests and striking them again and again until the shell breaks. Some even carry favorite stones tucked in their armpit pockets, using the same tool repeatedly over time. It's not random. It's personal, chosen, remembered. Astonishingly, even insects have demonstrated surprising problem-solving skills. In one experiment, bumblebees learned to roll a tiny ball into a goal to receive a sugary reward, and when shown that another ball was closer, they abandoned their earlier learned behavior and used the more efficient option. They adjusted, improved, optimized. Capuchin monkeys in the wild have been observed cracking nuts with stones. Some select specific rocks for the job: hard, flat, and heavy. They carry them across distances, remember their hiding spots, and even show younger monkeys how to use them. One group was seen washing sandy fruit in the river before eating it. These aren't just clever habits, they're solutions to daily challenges. Acts of applied intelligence pass through observation and repetition. And then there are dolphins. In shallow waters, they pluck sponges from the seafloor and wear them on their snouts like gloves, protecting themselves as they root through rough sand for hidden prey. This behavior isn't universal, it's local. Passed down through generations, mother to daughter, a cultural solution to a physical problem. In another case, dolphins cooperatively herd fish into tight balls, taking turns feeding while blocking escape routes. They coordinate, strategize, and adapt to the fish's behavior in real time. Problem solving in the animal world often reveals itself through persistence, through the willingness to try again with a different approach. A parrot faced with a multi-step puzzle doesn't peck aimlessly. It pulls a lever to release a latch, then lifts a cover, then spins a wheel, all to access a hidden treat. Each step builds on the last, and once learned, the sequence is remembered and applied with less trial, more intent. Even rats, often overlooked, have shown remarkable adaptability. When placed in mazes with shifting pathways, they learn the new layouts quickly, building spatial maps in their minds. Some can even infer the shortest path between 2 points they've never traveled directly, using logic to fill in the gaps. In another study, rats were given a choice between immediate small rewards and larger delayed ones. Some waited, exercising impulse control in exchange for greater gain. Not every human toddler can do that. These glimpses into animal problem solving are not isolated tricks. They are patterns. Patterns of reasoning that span oceans and ecosystems. Patterns that point to something shared. The ability to encounter a challenge and respond not just with instinct, but with thought. And when we look closely, we begin to see that intelligence is not always loud or complex. It can be quiet, focused, unassuming. It can live in feathers and fins, in trunks and tentacles. It doesn't always need a voice to be heard. Across the wild, animals meet their world with questions. Where is the food? How do I get? What stands in my way? And more importantly, how can I change the outcome? In their silence, in their methods, in the elegant solutions they devise, they show us that intelligence wears many forms, and that a thinking mind does not always look like our own. Some lies are told with words, others are told with wings, with feathers, with flicks of the tail, or sudden collapses onto the ground. In the wild, deception is not a moral failing, it's survival. And for many animals, the art of the lie has been honed to a science, practiced not in cruelty, but in cleverness. It is not always the strongest that thrive, but the most convincing. Picture a bird in the underbrush, fluttering away from its nest with one wing dragging behind it. It flails, limps, trembles. A predator watches, curious. The bird appears injured, vulnerable, easy prey. And just when the predator lunges, the bird takes off in a perfect arc, uninjured, leaving the intruder far from her hidden chicks. The killdeer is a master of misdirection, feigning weakness to protect her future. It's theater, performed with precision, instinctively choreographed to save lives. In the coral reefs, there is a fish known as the mimic octopus. It shifts its skin from pale to striped, reshaping its arms and posture to resemble lionfish, sea snakes, or flatfish depending on what's around. If a predator that avoids sea snakes approaches, the octopus becomes one. If a creature fears lionfish more, it adjusts, it watches, it chooses. This is not just camouflage. It is impersonation, context-aware and deliberate. Deception takes many shapes. In Africa, fork-tailed drongos follow meerkats, calling out real alarm cries when predators are near. The meerkats scurry for safety, and the drongo swoops in to steal the food they left behind. But the drongos don't stop there. Once the meerkats catch on, the bird switches tactics, mimicking the alarm calls of the meerkats themselves. It lies in their own, two language. It waits for trust to be rebuilt. Then it lies again. Even insects get in on the game. Some butterflies wear false eye spots on their wings, fooling predators into striking the wrong end. Others mimic leaves so perfectly that even in daylight, even up close, they disappear. There are caterpillars that imitate bird droppings, not by accident, but as a calculated disguise. The world is filled with fakes, and each one is alive because it convinced someone not to look closer. In a dusty clearing, a male cuttlefish slides between two larger rivals competing for a female. He changes color on one side of his body to look like a female, avoiding detection while flashing his true colors toward the object of his affection. To one side, he is a suitor. To the other, a decoy. And it works. He mates undisturbed, then glides away before the others realize they've been outwitted. His deception is half physical, half psychological. Closer to home, scrub jays hide their food from other birds. But if they've been thieves themselves, if they've stolen from others in the past, they behave differently. They re-hide their food when they think another jay might be watching. The more dishonest their history, the more paranoid they become. They project their own tactics onto others. In a way, they imagine what they themselves would do and act accordingly. It's a kind of empathy built on mistrust. Spiders, too, know how to lie. The bola spider releases a scent into the air that mimics the pheromones of a female moth. Male moths, drawn in by the illusion, flutter toward what they think is a mate. Instead, they find the spider waiting with a sticky ball of silk, swung like a lasso. It is seduction by scent, a fatal promise. Sometimes, the lie is in the body itself. In the rainforest canopy, a caterpillar coils and sways like a venomous snake. When disturbed, it inflates parts of its head to complete the illusion. The deception doesn't require memory or reasoning, it simply works. Evolution has written the script, and the actor performs it flawlessly. And yet, in some cases, the deceit becomes conscious. Orangutans have been observed creating fake alarm calls to distract others from a food source. Dolphins will sometimes mislead researchers during training exercises, hiding objects they've been asked to retrieve, and only returning them when they sense a better reward is on offer. These aren't flukes, they are strategies. Each one a small, calculated performance designed to alter behavior in others. Even the velvet ant, really a wasp in disguise, flaunts bright warning colors that mimic those of truly dangerous species. Predators avoid them instinctively. The lie is worn like armor, and over time, the cost of being mistaken has become too high. The deception works not because it's perfect, but because it's good enough to cause hesitation. And in nature, hesitation can be fatal. In icy waters, orcas create waves to knock seals from ice floes. If the seal survives the first hit, the orcas sometimes pretend to swim away, only to circle back once the seal has relaxed. This tactic isn't just brute force, it's patience, a kind of hunting that blends psychology and persistence. Even humans have been fooled. There are birds that mimic the sounds of ringing phones, car alarms, and chainsaws. The lyrebird's song is a collection of stolen sounds, each one reproduced with stunning accuracy. It's not clear whether the mimicry has a purpose beyond impressing mates, but the result is the same. A song that deceives the ear, a trick played on our modern minds. Deception, in the animal world, is not an accident. It is a tool, a strategy, a language beyond words that changes outcomes, protects the weak, and gives the clever an edge. It blurs the line between instinct and intellect, between survival and manipulation, and it reveals something strange and thrilling, that the ability to lie, to mislead, to pretend, is not uniquely human. It exists in feathers, in fur, in skin and scale and scent, in shadows and mimicry. in stories told not with words, but with form, color, motion, and sound. Nature is full of actors. Some wear masks, others write scripts in silence, but all of them, in their own way, remind us that truth in the wild is often just the most convincing illusion. In the golden stillness of an African savanna, a young elephant stands beside the sun-bleached bones of its mother. It doesn't sniff and move on. It lingers. Its trunk gently traces the curve of a tusk, brushing against the skull with a reverence that looks almost human. There is no practical reason for it to stop here. No food, no danger, no gain. But it does, and it stays. Eyes half-lidded, breath slow and deliberate, as if remembering, as if mourning. For decades, stories like this were dismissed as coincidence or projection. We were told animals don't feel as we do, that emotion belonged to our species alone. But the evidence, now, is too rich, too varied, and too deeply moving to ignore. Grief is one of the clearest windows into an animal's emotional world, and yet it's one we once refused to see. In pods of orcas, mothers have been seen carrying their dead calves for days, sometimes weeks, lifting them again and again to the surface, unwilling to let go. In one case, a mother named Tahlequah carried her lifeless newborn for 17 days, traveling over 1,000 miles. Scientists called it a tour of grief. Observers wept. There was no denying the meaning behind her actions. This was not instinct. This was love refusing to fade quietly. And love, as it turns out, is everywhere. In the wild, bonded animals share more than territory. They share comfort, touch, and time. When prairie voles pair, their bond is monogamous, often for life. They nest together, groom one another, and show signs of stress when separated. If one dies, the other's behavior changes. Their cortisol levels spike. Heart rates climb. They grieve. In ways not unlike us, dogs, too, exhibit signs of mourning, curling up on their owner's belongings, refusing food, waiting by doors that no longer open. They don't understand death the way we do, but they feel the absence, the quiet that follows, the shape of a presence no longer there. Emotion is not always sadness. Sometimes it's jealousy, a raw, often sharp emotion that reveals how socially aware an animal truly is. In one experiment, 2 dogs were taught to perform a trick for a treat. At first, both received a reward. But then, only one did. The unrewarded dog began to refuse the command, pawing the air, glancing between the handler and the other dog. It wasn't just about the treat. It was about fairness. The dogs compared their outcomes and reacted with visible frustration. Monkeys have done the same, rejecting cucumber slices when they see a peer get grapes instead. They protest, they pout, they refuse. They know what's fair and what isn't. In the rainforest, capuchin monkeys console one another after fights. They embrace, stroke fur, sometimes pressing their faces together in a kind of silent apology. Ravens have been observed doing the same. When a fight breaks out in a group, bystanders approach the victim afterward, offering comfort, touching, preening, vocalizing softly. Empathy is not reserved for humans. It lives in feathers and fur, in wings and paws. There's a kind of emotion that blooms in anticipation, in joy. You can see it in the way elephants trumpet and rumble when reunited after time apart, rushing to one another in great waves of movement and sound. In the way dolphins leap higher when their favorite humans approach, or how gorillas greet old caretakers after years apart, holding their gaze with something more than curiosity, something closer to recognition, even affection. Rats, when tickled, emit ultrasonic chirps, a kind of laugh too high-pitched for our ears without equipment. When given the choice, they return to the hands that tickled them. They seek out joy. They remember what felt good. In mazes, they help each other, freeing trapped companions even when no reward is offered. Compassion does not always need a motive. Even chickens, often dismissed as emotionless or robotic, show empathy. When a mother hen sees her chicks in distress, her heart rate rises. She clucks with urgency, becomes more alert, more agitated. She feels their fear. Mirrors of emotion aren't exclusive to primates or pets. They stretch across species lines, woven into evolution not as decoration, but as survival. Emotion shapes how animals bond, how they parent, how they fight, forgive, and play. When ravens engage in games tug of war, aerial loops, teasing they're not just passing time, they're practicing social nuance, learning trust, and experiencing what can only be described as fun. And when play turns rough, some pause to check on. their partner, waiting for a signal before continuing. There are rules, and there is care. Even among insects, there are strange glimmers of feeling. Bees show signs of pessimism after stressful events, hesitating longer before exploring new areas, avoiding uncertain choices. It's not emotion in the way we feel it, but it's a shift, an internal state that colors behavior. The emotional lives of animals are not simple echoes of our own. They are unique. They're built from different bodies, different senses, different needs, but they are real. And once we allow for that possibility, the world becomes richer. A crow calling for its lost mate, a bonobo embracing a frightened infant, a dog that curls beside a coffin and stays. These are not curiosities. They are expressions of feeling, shared across the boundaries of species and sound. We are not alone in loving, or grieving, or remembering. The heart beats in many shapes, and across the earth, emotion moves quietly, patiently, invisibly through the animal kingdom, whispering that to feel is not uniquely human, it is simply alive. In a snowy clearing, a young fox leaps into the air and lands belly first on a patch of ice, sliding clumsily before scrambling back to try again. There's no prey here, no predator, no reward, just motion, laughter unspoken, and the thrill of repetition. A moment later, it does it again, ears perked and eyes bright. Something in that slippery tumble makes the world feel right. This is play, one of the most mysterious and beautiful behaviors in the animal kingdom. Not quite instinct, not quite strategy, something looser, freer, and strangely familiar. For a long time, scientists struggled to explain why animals would burn energy on games that seemed to serve no immediate purpose. But again and again, from the deepest oceans to suburban backyards, animals choose joy. They choose practice. They choose games. And in doing so, they reveal a kind of mind that is not just functional, but curious. Take dolphins. They are known for their acrobatics, their complex vocalizations, and their undeniable charm. But beneath that surface is a deep current of playfulness. In the wild, dolphins chase one another in synchronized spirals, toss seaweed back and forth like a baton, and ride the wakes of passing boats purely for the sensation. Sometimes, they blow bubbles, perfect, shimmering rings, and spin through them like hoops. Not because they must, because they can. This kind of play isn't random. It has rules, intentions, and feedback, and it's often social. Dolphins switch roles during chasing games. The chaser becomes the chased. The balance of power shifts, not in competition, but in fairness. Like children taking turns in a game of tag, it shows an understanding not just of self, but of others, a sense of mutual enjoyment. Crows and ravens, too, are famous for their intellect, but they are also deeply playful. In one video, a raven slides down a snowy rooftop on a piece of plastic, retrieves it, climbs back up, and does it again. There's no food at the bottom, no rival to impress, just the joy of sliding. Other ravens play catch mid-air, flipping sticks and feathers back and forth. Some even tease dogs, swooping low to trigger a chase, then escaping with ease, only to return for another round. Young elephants play fight with their trunks, mimicking the movements of adults, but with far less force. They push and tumble, splash through mud, and trumpet in short bursts that sound remarkably like laughter. Play teaches them coordination, social cues, and boundaries, but it also seems to exist for its own sake. When they're not learning, they're simply enjoying, testing the weight of their own joy. Even reptiles, long thought to be emotionless and cold, have shown signs of play. In controlled environments, some monitor lizards have been observed repeatedly pushing balls, chasing strings, and engaging with toys in ways that can't be explained by hunger or curiosity alone. One even learned to flip a door latch, not to escape, but to do it again and again, as if solving the puzzle brought a kind of satisfaction. Domesticated animals offer some of the clearest windows into play. Dogs invent games with humans and each other, using signals like play bows to invite interaction. They understand the difference between aggression and gamesmanship, holding back their bite, exaggerating their movements, laughing with their bodies. Cats chase shadows, stalk invisible prey, and sometimes sprint wildly across the room for no reason at all, except, perhaps, because it feels good to run. In the sea, young humpback whales have been seen playing with kelp, draping it over their heads and rolling in it like children in tall grass. Sea otters crack shells on their bellies with stones, but they also juggle those stones, tossing them between paws in a hypnotic rhythm. The action serves no function during feeding, it's just something they do, over and over, as if the motion itself is a kind of meditation. Play appears early in life, but it doesn't disappear with age. Older animals play, too, though sometimes in quieter ways. A horse nuzzling a companion, a parrot bobbing its head to music, a chimpanzee drawing with charcoal or smearing paint on a canvas. These acts aren't necessary. They're not rewarded with food or status, but they're chosen. And that's the heart of play. It's voluntary, a self-created joy. But play isn't always lighthearted. Sometimes it's a rehearsal for real life. Predators practice the chase. Prey practice the escape. Social animals test hierarchies, push boundaries, and learn trust. Through play, animals simulate conflict, negotiate relationships, and stretch the limits of their minds and bodies without real-world risk. It's nature's sandbox, an invisible classroom where the lessons are physical, emotional, and often unseen. Perhaps most striking is the way play connects animals to each other. It builds bonds, strengthens empathy, teaches rules and cooperation. When two polar bear cubs tumble across the snow, they're not just burning energy. They're learning when to stop, how to read cues, how to take turns. And when one cub whimpers, the other often pauses. There is awareness in their games, a sensitivity, a thread of connection running beneath the chaos. Humans are not alone in finding delight in the unnecessary, in chasing for fun, in pretending, in creating small moments of magic in an otherwise serious world. And it's this, more than tools, more than language, that hints at a shared core of consciousness. The awareness, not just of the world, but of one's place in it. The ability to manipulate not just objects, but mood. To play is to imagine another way of being, a different outcome, a story not yet told. And across the planet, animals are telling those stories in ice and ocean, in forest and field, not with words, but with movement, rhythm, and joy. With games invented in real time, with laughter that doesn't need sound, with a spark that reminds us that intelligence isn't always measured in logic or language, but in the freedom to choose wonder, to spin, to leap, to play. In a meadow brushed by sunlight, a honeybee circles in wide, lazy arcs above a field of flowers. It dips, lands, gathers what it needs, then takes off again, rising into the air and turning toward home. But the hive is nowhere in sight. There are no signposts, no trails, no visible path. And yet the bee knows exactly where to go. It flies with purpose, slicing through the air on a route that seems invisible to us, but written clearly in its mind. This is not guesswork. It is navigation, an ancient kind, born long before maps or machines. The kind written into the bodies of creatures that move by memory, by starlight, by the subtle pull of Earth itself. Bees are among the smallest of navigators, but their skills rival those of pilots. After foraging, a bee returns to its hive and performs a dance, part circle, part waggle, moving in a figure eight that encodes direction and distance. The angle of the waggle tells others where to fly in relation to the sun. The duration of the dance reveals how far. Its geometry performed in shadow and motion, a language of orientation shared among thousands. Somehow, their tiny brains process angles, light, and time to chart a path across miles. Even when the sun shifts in the sky, they adjust, they correct, they compensate, all without ever seeing the world from above. Birds, too, are masters of movement. Arctic terns travel from the top of the world to the bottom and back again, chasing summer across the hemispheres. It is the longest migration on Earth, over 44,000 miles round trip. They pass over continents, through storms, across endless stretches of ocean. And yet they do not lose their way. Even fledglings, flying alone for the first time, find the path without guidance. They navigate using cues we are only beginning to understand. The angle of the sun, the tilt of the magnetic field, the scent of the sea carried by air. Inside the heads of pigeons, there is something stranger still. Studies suggest they carry a map built from the Earth's magnetic field, one that may rely on magnetite tiny crystals of iron in their beaks or brains. When displaced, even hundreds of miles from home, they turn and fly toward their lofts with eerie precision, not just in open landscapes, but through cities, forests, and mountains. If clouds block the sun, they still find north. If magnets are attached to their bodies, they falter. Something inside them feels the planet itself, an internal compass, calibrated without instruments. Sea turtles hatch in darkness, guided by the moon's reflection on water. They slip into the surf and vanish for years, drifting through vast gyres of ocean, sometimes crossing entire basins before returning to the same beach where they were born. No map leads them there. No one shows them the way. Yet loggerhead turtles, after swimming more than 9,000 miles, curve back to the very sand they first touched. Researchers believe they imprint on the magnetic signature of their birthplace a unique pattern of field strength and inclination, like a fingerprint of the earth itself, stored in the folds of memory. In the sky, bar-tailed godwits soar from Alaska to New Zealand in a single, unbroken flight, more than 7,000 miles without rest, food, or water. They cross the equator, battle headwinds, and navigate without landmarks. The journey takes over a week, but they arrive, every time, in the right place. Their brains hold maps of air pressure, sun angles, and wind patterns. Even as they fly above clouds or at night, they adjust their heading with incredible accuracy. This is not inherited knowledge in the abstract. It's applied, precise, alive. Even salmon, whose lives begin in freshwater streams and stretch into the open sea, find their way back with stunning fidelity. After years in the ocean, they return to the very river, even the very tributary, where they began. They detect chemical signatures in the water, using scent as a guiding star. Each stream smells slightly different, a signature composed of minerals, silt, and decay. The salmon reads it like a poem, like a name whispered in current. And upstream they go, leaping waterfalls, dodging predators, pulled not just by instinct, but by memory, etched into body and bone. Insects, too, carry inner maps. Monarch butterflies migrate across entire continents, fluttering from Canada to Mexico across generations. No single butterfly makes the round trip, and yet the route is preserved, passed on. A whisper in the wings. Scientists believe the monarchs use the position of the sun, compensating for the time of day with a kind of internal clock. They adjust their angle as the hours pass, holding a heading that no individual has ever flown before, but all seem to know. There are animals that chart their way by smell, by sound, by the stars. Whales sing songs across thousands of miles, their low-frequency calls bouncing off seafloor and coastlines. Some believe these songs help them navigate. Others point to memory, to experience, to years of pattern and place stored in a brain the size of a suitcase. And in all of them, there is an echo of something we once had the ability to know, where we are not from signs or screens, but from sensation, from feeling, from an unspoken dialogue with the earth. Navigation in the animal world is not just movement. It is memory, orientation, calculation, and sometimes something that looks like wonder. It is a knowledge older than cities and satellites, crafted by evolution, refined by time. These creatures don't simply survive. They move with purpose across vast distances, reading a language we can't quite see but know exists. And so the bee dances, the bird arcs, the turtle swims, the whale sings, all guided not by maps, but by minds that remember the way. Minds tuned not to machines, but to the quiet pulse of the planet beneath them. A map made not of paper or pixels, but of light, scent, magnetism, and sky. In a quiet German forest in the early 2000s, a border collie named Rico was making history. Not with tricks or obedience or agility, but with something far stranger. Words. Rico knew over 200 of them, names of toys scattered throughout his home. When a new toy was introduced, and all the others were laid out before him, Rico could pick out the unfamiliar object with eerie accuracy, simply by inference. If he knew the names of all but one, then the one he didn't recognize must be the one with the new name. It was a leap of logic once thought exclusive to children, to language-using minds. But there it was, padding across the floor on 4 white paws. The study stunned researchers. Rico wasn't mimicking. He wasn't just conditioned. He was thinking, reasoning, deducting, and he wasn't alone. In Austria, a parrot named Alex was reshaping what people thought a bird could understand. Trained and loved by animal psychologist Irene Pepperberg, Alex didn't just parrot human speech, he used it. He knew shapes, colors, quantities. He understood the concept of same and different, of bigger and smaller. When shown a red key and a red cup and asked, "What's the same?" he said color. When asked what was different, he said, "Shape." His answers were not rehearsed. They were spontaneous. He even coined his own words, calling an apple a bannery, a blend of banana and cherry, two fruits he already knew. These weren't coincidences. They were demonstrations. Proof that intelligence flows in unexpected directions, across feathers and fur, not limited by species or skull. Shape. In a different lab, a New Caledonian crow was solving a puzzle that required 3 separate steps. First, it had to use a small stick to pull out a longer stick, then use that to reach a stone, then use the stone to drop into a tube and raise the water level to get a treat. It was a cascading series of cause and effect. The crow paused, considered, then executed each move in order, without trial and error. It was not rote memorization, it was planning, imagination perhaps, a mental rehearsal before the first attempt. In one of the most elegant experiments of all, psychologist Wolfgang Kohler presented chimpanzees with bananas hanging just out of reach and boxes scattered nearby. Rather than jumping aimlessly, one chimp named Sultan stopped, looked, then calmly stacked the boxes, climbed atop them, and claimed the reward. No one had shown him how. It was a quiet moment of problem-solving, of invention in real time, a glimpse into the inner machinery of thought, but not all the genius comes from apes and birds. In the ocean, octopuses have become notorious for their mischief. In one experiment, an octopus learned to unscrew a jar from the inside to escape. In another, one repeatedly squirted jets of water at a light it seemed to dislike, shorting it out. At a public aquarium, staff couldn't figure out why fish in a nearby tank kept vanishing until a nighttime camera revealed the octopus slithering out, hunting silently under the cover of dark, then returning before dawn. Some scientists believe octopuses may dream, their skin shifting colors as they sleep, flashing the patterns of their waking camouflage as if recalling memory. Their intelligence is distributed, each arm capable of semi-independent action, rich in neurons. They don't learn through teaching, but by observing, experimenting, and remembering. Back on land, elephants have demonstrated self-awareness in ways long thought beyond non-human animals. In a mirror test, an elephant, named Happy, was marked with a white X, visible only in reflection. When shown a mirror, she inspected her body, touched the mark with her trunk. She recognized the image as herself, not another elephant, not an illusion. Only a handful of species pass this test: great apes, dolphins, magpies, and Happy, with her massive frame and quiet grace. In labs and sanctuaries, bonobos have used touchscreens to communicate, choosing symbols for food, play, even emotions. Coco the gorilla learned over 1,000 signs in American Sign Language, using them to express love, sadness, even grief after the loss of her pet cat. Some skeptics questioned the interpretation, but those who lived and worked with Coco described something else: emotional clarity in a form no one expected. One study placed rats in an enclosure with 2 compartments, one with food, the other with a trapped companion. The free rat would often forego the food to release the other. Empathy, it seemed, was not the exclusive property of higher primates. It existed in the smallest of minds, too. And then there are the cleaner wrasse small tropical fish, once overlooked in the study of cognition. In 2019, they became the first fish to pass the mirror test. When marked with a colored dot, they swam to the mirror, twisted and turned, then attempted to scrape the mark off by rubbing their bodies against rocks. It shook assumptions. Fish, previously thought to operate purely on instinct, were suddenly seen in a different light. What these experiments reveal is not just brilliance, but variation. Intelligence doesn't look the same in every species. It adapts. It reflects the world the animal inhabits. A raven may solve a puzzle in midair. A dolphin may invent a new trick without prompting. A chimp may weigh social consequences before making a move. Each kind of genius is shaped by the life that carries it, and it forces us to ask, how much have we missed, simply because we didn't think to? Look, because we expected intelligence to sound like us, act like us, speak in our words. Across decades of research, the veil has slowly lifted. The old myths that animals are automatons, that they do not feel or think or choose, have crumbled. In their place is something far more intricate, a planet humming with minds, all solving, learning, adapting, and dreaming in their own extraordinary ways. In the shallows of a coral reef, a mantis shrimp lies hidden among the rocks, its bulbous eyes swiveling independently like sentinels. To the human gaze, this world is already bursting with color, but to the mantis shrimp, it's a pale imitation. Where we see a rainbow, they see a spectrum that spills far beyond it. Humans have 3 color receptors: red, green, and blue. The mantis shrimp has 12. It can see ultraviolet and polarized light, and possibly colors we don't even have names for. For them, the ocean is painted in dimensions our brains are not equipped to fathom. These creatures do not just live in another world, they see another world. Throughout the animal kingdom, evolution has crafted senses that slip past our perception, revealing that what we experience is only a fraction of reality. Beneath our awareness, many creatures navigate, communicate, and hunt using sensory tools that feel almost like superpowers. Consider the star-nosed mole, a creature that tunnels in total darkness. Its namesake appendage is a fleshy ring of 22 tentacles packed with over 25,000 sensory receptors called Eimer's organs. In just a fraction of a second, it can identify prey by touch alone. Its brain processes these touches so quickly that it might as well be seeing with its nose. It can detect shape, texture, movement, all from brief contact in blackness. It experiences the world not through sight or sound, but through pressure and vibration, assembling a mental image as detailed as any painting. Bats fly by sound. Not just the passive hearing we rely on, but echolocation, emitting high-frequency chirps and reading the echoes that bounce back. In darkness, this allows them to map their surroundings in astonishing detail, tracking insects mid-flight with near-pinpoint accuracy. Some species can distinguish objects as fine as a human hair stretched across a room. They don't see the night, they hear its shape. Dolphins and whales use a similar method underwater. Their clicks, whistles, and pulses paint acoustic portraits of the sea around them. Some dolphins can detect the difference between a hollow metal sphere and a solid one just by the echo. Pregnant women swimming with dolphins have sometimes reported the animals lingering nearby, as if drawn to the sound of a second heartbeat. It's led some researchers to wonder, do dolphins echolocate the unborn? Do they see inside us with sound? Meanwhile, in the skies, birds migrate across continents using cues we're only beginning to understand. It's believed that many can see the Earth's magnetic field, possibly as a shifting visual overlay across their vision. The European robin, for example, has a light-sensitive protein in its eye called cryptochrome that may allow it to detect magnetic direction. If true, it means these birds can actually see north, a glowing thread stitched across the world, invisible to us, but clear as daylight to them. Then there are animals that sense vibration. Elephants communicate over miles through subsonic rumbles that travel through the ground. Their feet, dense with vibration-sensitive cells, can feel the seismic pulses of a distant herd or the warning signals of approaching danger. They know each other's movements without sound or sight, connected through the trembling skin of the earth itself. Bees navigate by reading polarized light patterns in the sky, subtle shimmers, invisible to the human eye. Even on cloudy days, this helps them determine the sun's location. They also detect electric fields, sensing the slight charge difference between a flower and the air around it. When a bee lands, it discharges that electric field, leaving a temporary signal for others that says, "This flower has already been visited." It's a kind of electrical handwriting passed between wings and petals. Sharks, gliding silently through the ocean, carry another secret sense: electroreception. Tiny pores called ampullae of Lorenzini dot their snouts, sensitive to the faintest electric fields produced by muscle contractions or the beating hearts of prey. Even buried under sand, a flounder cannot hide from a shark that listens with its face. To a shark, stillness isn't invisibility, it's just another form of signal. Some snakes, like pit vipers, detect infrared radiation through specialized organs on their faces, allowing them to see heat. In total darkness, a mouse's warmth glows like a lantern. The snake's brain combines this input with its vision, creating a dual image, a world of shape and temperature. For them, life burns with light we cannot perceive. Even humans, in rare cases, reveal glimpses of lost or latent senses. People born blind sometimes develop heightened touch or echolocation skills, clicking their tongues and interpreting the echoes off walls and objects. But for most of us, the world remains narrowly filtered, processed through 5 well-worn pathways: taste, touch, smell, sight, sound. Reliable, yes, but incomplete. Because out there, the world hums with signals we cannot grasp. A whale's low-frequency song may ripple for hundreds of miles, unheard by us. A bee sees ultraviolet patterns on petals that to us are plain. A bird navigates by a field we can't feel. These animals are not just behaving differently, they are perceiving differently. Living in sensory tapestries stitched from data we don't even know we're missing. It challenges what we mean by reality. Each species lives in its own sensory bubble. What the biologist Jakob von Uexküll called an Umwelt, a subjective universe shaped by perception. For a bat, reality is an echo. For a mole, a vibration. For a shrimp, a rainbow that never ends. We move through our days, thinking we see the world as it is, but the animal mind shows us something deeper. We each see the world only as we are built to see it, and far beyond our reach, in the quiet places of forest and ocean and sky, countless minds are watching, hearing, sensing, and knowing a world that will never quite be ours. In the hush of early morning, a young orangutan clings to its mother's side as she swings through the rainforest canopy, one arm stretched from branch to branch with practiced ease. The baby watches everything, how she tests a vine before trusting it, how she selects the ripest fruit, how she folds leaves into a makeshift umbrella when the rain begins to fall. There is no classroom here, no chalkboard or checklist, but every movement is a lesson, every shared glance, a cue in this green cathedral of life. Learning begins not with words, but with watching. Childhood in the animal world is not just a waiting room for adulthood. It is a time of deep transformation, of sculpting instinct into skill. For many species, it's the longest and most vulnerable chapter, a time when survival depends not just on strength, but on guidance. A lion cub learns to stalk by crouching in tall grass and pouncing on a sibling's tail. A wolf pup mimics the body language of the pack, learning who to challenge and who to follow. Young elephants, born into tight-knit families, watch their elders carefully, absorbing knowledge passed down through generations, where to find water in drought, how to mourn a fallen kin, when to be playful, and when to stand firm. Among crows, fledglings engage in what looks like aimless play, tossing sticks, flipping bottle caps, solving small puzzles. But these games have purpose. They rehearse problem-solving, test coordination, and allow the young to discover how the world bends, resists, and surprises. In some cases, older crows will even leave tools near their young, nudging them toward a solution, but never handing it outright. It is the art of teaching without speaking, the patient offering of a question, not the answer. In oceans, young dolphins stay with their mothers for years, learning the dialect of their pod, the layout of reefs, and the meaning of subtle social cues. In some pods, mothers will catch a spiny fish, despine it, then offer it to their calf, a delicately timed lesson in foraging. Others teach by example, using tools like marine sponges to stir the seafloor and revealing to their young that not all food is found by sight. These lessons pass through families like heirlooms, and the knowledge, once rare, becomes tradition. Whales, too, inherit more than genes. Humpback calves travel thousands of miles alongside their mothers, listening to songs that ripple through the water. These songs are complex, structured, and slowly evolve over time. Young whales memorize the current chorus and add their voices to it, perpetuating a shared language that echoes across oceans. In this way, even songs become cultural learned behaviors passed through listening, not biology. In Africa, young meerkats are taught to handle dangerous prey in stages. An elder will first present a dead scorpion, allowing the pup to explore it without risk. Then, a live scorpion with the stinger removed. Finally, a fully intact scorpion. At each stage, the pup learns through action, trial, and encouragement. This kind of teaching, adapting lessons to the learner's skill, is rare in the animal world and speaks to a level of empathy, of intention, that we are only beginning to understand. Some learning is not just parental. It comes from siblings, peers, or even the broader group. Young parrots learn their vocal signatures from the flock, shaping their calls to reflect not just who they are, but who they're with. In chimpanzee communities, tool use varies from region to region, not because of genetic differences, but because of what the young observe. One group may use sticks to fish for termites, another may use stones to crack nuts. These are local customs, learned through imitation and repetition. They are culture, carried forward by children, and sometimes, animals learn from us. In urban environments, animals adapt with startling speed. Raccoons learn how to open garbage bins, memorize garbage collection schedules, and navigate traffic patterns. Pigeons recognize human faces, distinguishing between those who feed them and those who shoo them away. Crows in Japan drop nuts onto crosswalks, waiting for the lights to change so passing cars can crack the shells, then they swoop in when it's safe. These behaviors are not random. They are studied, repeated, refined. In captivity, young primates raised by humans often adopt human gestures, waving, pointing, even making faces in the mirror. They mimic what they see, not because they're trained, but because learning is woven into their nature. In sanctuaries and research settings, apes have learned sign language, watched videos, solved complex puzzles on tablets. They are not just absorbing information, they are reaching for understanding. But not all learning is functional. Like human children, many young animals seem drawn to play for its own sake. Baby goats bounce erratically on hillside rocks, practicing balance and daring. Young sea otters wrestle in the kelp, spinning and tumbling, testing the give of their environment. Through play, they learn physics, boundaries, and trust. They learn what it feels like to fall and how to get back up. And woven through all of this is memory. Young elephants remember water holes visited only once, years ago. Young bears taught by their mothers return to the same berry patches, fishing spots, and migration paths. Even in the absence of the teacher, the lesson endures. Childhood is the furnace where intelligence is forged. It is not empty time, but vital time. A dance of curiosity, failure, repetition, and triumph. And when we look closely, when we pay attention not just to what animals do, but to how they begin, we see something striking. We see the spark of mentorship, the passing of wisdom, the shaping of identity, not by biology alone, but by experience. In these quiet moments, when a lion cub mimics a pounce, when a dolphin calf echoes a whistle, when a baby gorilla watches its mother crack a nut, we are witnessing the birth of knowledge, not instinct, but learning, not command, but discovery. And in those tiny gestures, those glances, those experiments with the world, a new mind takes shape, one that belongs to the animal and to the world it is learning to understand. In the depths of an Australian forest, under a canopy of rustling eucalyptus and filtered gold, a satin bowerbird gathers his treasures, bits of blue plastic, shiny beetle wings, petals the color of twilight. He arranges them with careful precision around the entrance of his bower, a woven archway of twigs, neither a nest nor a shelter, but something stranger, a stage, a gallery, a declaration. The bower isn't for sleeping, nor for feeding, nor protection. It is for being seen, for being admired. The male dances in front of it, puffing his feathers, making odd, guttural calls, tilting his head toward the entrance. But the real performance is in the arrangement itself, the way he has chosen and placed each object, not haphazardly, but with intent, with taste. He is not the only artist in the animal world. Across species and habitats, there are creatures who seem to go beyond the practical, who decorate, compose, and sometimes even invent, not to solve a problem or catch prey, but to express, to attract, to engage, to make something beautiful. In the tropical waters of the Pacific, a small fish begins to move, sand. It swims in concentric circles, pushing the fine grains outward with delicate flicks of its fins. Over days, even weeks, a pattern emerges, a sprawling mandala, nearly 6 feet across, etched into the seafloor like a living crop circle. At the center sits a slightly raised nest. This is the work of a male pufferfish, who labors with astonishing precision to create these geometric sculptures in the hopes of attracting a mate. The patterns are not random. They ripple with symmetry, with peaks and valleys, with deliberate imperfections that catch the eye. When the currents smooth it away, he begins again. The work is fragile, but that only seems to make it more urgent. Some birds don't build at all, but sing. The song of a nightingale is layered and fluid, composed of over 200 different notes. Males improvise, recombine, and adjust based on the context who is listening, where they are, what time of day. These aren't static calls. They're performances, shaped by feedback, memory, and mood. Whales, too, create songs that change slowly over time, pass through generations like folk ballads of the sea. Entire pods adopt new motifs, dropping old phrases and adding new ones, sometimes influenced by neighboring groups. The evolution of whale song resembles the evolution of music, complex, cultural, and responsive. And then there are elephants. In sanctuaries where paintbrushes are introduced, some elephants pick them up and begin to draw. With trunks curled carefully around the handle, they make lines on canvas, swirls, loops, patterns. Not every elephant is interested, but some return to the activity again and again, choosing colors, repeating familiar shapes, even creating forms that seem reminiscent of landscapes or flowers. Are they imitating their handlers? Perhaps. But there are cases where the marks appear unprompted, where the elephant paints alone, unobserved, and continues regardless of reward. We can't know what they're expressing, but the desire to make marks, to create, seems to arise naturally, as if the act itself is satisfying. In captivity, dolphins have been given underwater keyboards, each key linked to a color display. Some use them to choose favorite patterns, playing with rhythm and repetition. In one study, a dolphin named Akiakamai arranged objects in what researchers called orderly displays, separating by shape and color, adjusting the orientation of each item with noticeable care. There was no prize for doing so, no food, just a kind of quiet delight in arrangement. Octopuses, too, are collectors. In the wild, some individuals construct shelters from coconut shells, stacking and positioning them into makeshift homes. Others decorate their dens with shiny stones or broken glass, selecting specific items seemingly based on appearance. When offered colored Lego bricks, they sometimes integrate them into their lairs. Whether these choices serve a function or fulfill a curiosity, the selections aren't random. An octopus doesn't just grab what's closest, it chooses. Even spiders, known more for instinct than invention, build webs that sometimes reflect more than utility. Orb-weaving spiders often incorporate stabilimenta, zigzag patterns of thicker silk that vary in placement and size. Some suggest they may be for camouflage or predator deterrence, but others speculate they might serve no direct purpose at all, just flourishes, signatures on silk. In primate studies, chimps and gorillas, given paint or clay, often begin with curiosity, smearing, tapping, sniffing, but over time, patterns emerge. Some apes develop preferences for certain colors or revisit specific gestures. Coco, the gorilla, famous for her use of sign language, once painted a series of red strokes and then signed the word love. Was it coincidence? Projection? Or was there a link between feeling and form, one we're only beginning to see? The idea of animal art challenges a long-held belief that creativity is a uniquely human trait, that beauty is something only we seek for its own sake. But perhaps that boundary is softer than we imagined. Perhaps beauty itself is older than us, something that existed before language, before civilization, flickering quietly in the animal mind. It may not be art in the human sense, with symbolism and narrative, but it is something adjacent, something resonant. When a bowerbird arranges its mosaic of blue, when a whale rewrites its song, when a dolphin plays with light, we're glimpsing minds at play with pattern, with texture, with sound. We are seeing intelligence not just applied, but expressed, not to survive, but to delight. And in those moments, the line between instinct and intention begins to blur. The world becomes more mysterious, more alive. We are no longer the sole keepers of imagination. We are just one species in a gallery of creators. A scrub jay buries an acorn in the soil, pressing it down with its beak, glancing once over each shoulder as if to mark the spot with its mind. Days pass, then weeks. The landscape changes, winds scatter the leaves, rain darkens the dirt, and the forest shifts in scent and sound. But the jay returns, navigating back not only to the tree, not only to the grove, but to the exact patch of earth it had touched. With a few quick hops and a turn of its head, it plucks the acorn from beneath the soil, still intact, still waiting. It is an act of memory so precise it borders on magic, and yet it is not rare. Across the animal kingdom, memory is more than a mechanism. It is a tether, a thread stretching between what was and what might be. It weaves identity, shapes behavior, and, in some species, begins to sketch the contours of something even deeper, the self. Elephants, long regarded as emblems of memory, seem to carry maps in their minds. A matriarch may recall the location of distant watering holes last visited during a drought, years ago. She remembers the scent of long-departed companions and the low, rumbling calls of family lost to time. These memories are not passive. They are acted upon, retrieved in moments of crisis, invoked during migration. When a member of the herd dies, elephants pause, They approach slowly. They touch the bones with their trunks, turn them over gently, as if reacquainting themselves with someone they still know. They do not do this for strangers, only for those they remember. Orcas, too, exhibit memory that spans both time and geography. Mothers teach their calves hunting strategies that rely on the precise recall of where prey gathers, when tides shift, how ice forms. Pods separated by years can recognize one another by voice alone, greeting with spins and breaches as though no time has passed. These aren't just facts retrieved, they are relationships remembered. In a quieter corner of the world, cleaner wrasses, a small, tropical fish, pass a test once thought to mark the boundary between animal and human, the mirror test. When a colored dot is placed on their body in a spot they cannot see directly, they behave normally. But when shown a mirror, they begin to twist, contort, and scrape themselves in ways that suggest recognition. They don't treat the reflection as another fish. They treat it as themselves. In that moment, something stirs beyond instinct. A question, perhaps. What is on me? Or maybe even, what am I seeing? Magpies pass the mirror test. So do dolphins. So do elephants and great apes. The mirror is not just a surface, it is a revelation. It asks, do you know what you are? For most animals, we cannot answer with certainty, but there are clues in behavior and memory that suggest at least a glimmer of self-awareness. A rhesus macaque can remember the sequence of images it saw on a screen and reorder them accurately, not just by chance, but by conscious recall. A rat navigating a maze will pause, hesitate, and backtrack, not randomly, but with deliberation, as if reviewing the memory of where it has just been. Western scrub jays don't just remember where they've hidden food, they remember what type of food, how long ago, and whether it might have spoiled. If another jay was watching during the hiding, the first may return and move the stash to a new location. This isn't simple instinct. It's theory of mind. It suggests the jay can recall not just what it knows, but what another might have seen and remembered. That kind of memory is layered. It demands a model of the world, a sense of the past, and a prediction of what might come next. Some researchers now believe animals can mentally time travel, not just react to cues, but imagine future events. Scrub jays will prepare for hunger by caching food in places they associate with scarcity. Bonobos have been observed gathering tools they will need later, even if it means sacrificing a treat in the moment. This future thinking, once considered uniquely human, is beginning to appear in the flickers of animal behavior across species and contexts. At the heart of it all is memory, not just storage, but story, a way to knit experiences into continuity. Dogs remember routines, the sound of a car engine, the footfalls of a specific person. They grieve when companions disappear, waiting at doors, pacing the hours. Parrots call out the names of humans who have long since left the room. Some will use the words they learned only from one person and not from others, as if conjuring a ghost with each repetition. In the wild, animals recall landscapes that change across seasons. Migratory birds return to nesting grounds with the precision of satellite maps. Turtles, hatched on distant shores, swim across oceans only to return decades later to the very beach where their lives began. Something in them remembers. And perhaps the most haunting clue comes from animals who seem to recognize themselves not just in mirrors, but in time. Apes, shown videos of themselves performing past tasks, sometimes watch with curiosity, even confusion. They recognize the footage, but they know it is not happening now. There is a distinction, a before and after. This is where the idea of self begins to take shape, not as a static identity, but as something dynamic, an animal that remembers what it did, anticipates what it might do, and reflects on those differences, however faintly, is not merely reacting. It is inhabiting a sense of presence stretched across time. And while we may never fully grasp what it feels like to be a dolphin recalling a lost calf, or a raven remembering a human who once offered food, we can begin to understand that the minds around us are not empty vessels. They are filled with echoes, with impressions, decisions, preferences, and fears that emerge not just from genes, but from memory, from experience. In that way, the animal mind is not a shadow of our own. It is a mirror of nature's many ways of knowing, some clear, some clouded, but all reaching across years, across distance, across species, for something that might be called continuity. And within that continuity, perhaps something that might even be called self. In a quiet research lab, A chimpanzee named Susie sits in front of a mirror. At first, she startles, reaching out as if to touch another chimp, confused by the perfect mimicry. But after a moment, her movements change. She tilts her head, makes a face, then watches herself make it. She touches a mark on her forehead that wasn't there before, an odorless dye placed by a researcher while she slept. She doesn't reach for the mirror. She reaches for herself, and in doing so, she crosses a threshold. The mirror test, first devised in the 1970 seconds, was meant to ask a simple but profound question. Can an animal recognize its own reflection as itself? Not a rival, not a stranger, but me. For many, the mirror is just a shiny surface or the presence of a perceived intruder. But for a rare few, it becomes a tool for self-exploration, a doorway into a deeper awareness. Chimpanzees were the first to pass this test. After them, orangutans and bonobos followed suit, inspecting their teeth, examining hidden body parts, even making faces just to see them echoed back. Then came dolphins, creatures without hands but full of grace, who twirled and arched in front of mirrored panels, bringing their eyes close, turning to inspect scars, bubbles, and markings as if they understood the image belonged to them. Elephants, too, displayed behaviors suggesting recognition, touching marks on their heads, testing the mirror, using it not as a toy but as a window into their own bodies. Magpies, small and feathered, challenged assumptions. A bird traditionally considered too distant from mammals to cross. That mental boundary was seen scratching at a colored sticker on its neck after looking in a mirror, twisting and pecking until it was gone. This tiny act stirred a deep question. Is the mirror test only one kind of intelligence, filtered through our lens of what awareness looks like? Because what if self-recognition isn't just about mirrors? Dogs, famously loyal and intelligent, often fail the mirror test. They treat their reflections as another animal or ignore them entirely. But they pass a different kind of test, the scent-based equivalent of the mirror. Given samples of their own urine and that of others, dogs spend significantly more time sniffing the unfamiliar. They recognize what is theirs, what is not. Their self-awareness may be olfactory, not visual. Pigs don't pass the mark test either. But when placed in a room where food is hidden, only visible in a mirror's reflection, they quickly learn to use the mirror to find it. They understand the image's implications, even if they don't use it to examine themselves. This kind of problem-solving suggests a different kind of cognition, less about identity, more about inference. A quieter intelligence that doesn't shout but reveals itself in action. The mirror test may only scratch the surface. Some researchers argue it's not the definitive line between awareness and unawareness, but rather a specific kind of skill dependent on vision, on curiosity, on comfort with the unfamiliar. Some animals freeze or flee at the sight of their own reflection, not because they lack a sense of self, but because the mirror introduces a riddle their instincts were never designed to solve. Still, there is something remarkable about those who do, because self-recognition is more than vanity. It's the foundation for empathy. If I can recognize myself as separate from the world, I can begin to recognize that you are separate too, that you have feelings, desires, pain. This awareness becomes the soil from which compassion grows. It allows for imagination, for prediction, even for a kind of morality. And it also opens the door to loneliness. Because to be aware of yourself is also to know you are alone inside your own mind, that your thoughts are yours alone, that others can come close, can comfort, can touch, but not enter. It is a burden and a blessing. A mirror cuts both ways. In the wild, we don't often see animals confronting reflections, but we do see behaviors that hint at awareness. A crow adjusting its feathers after looking at a puddle. A gorilla turning to inspect a wound after seeing it mirrored in a window. A killer whale pausing beside a boat's reflective hull, staring at its own eye. These moments, brief as they are, suggest that self-perception might be more common than we thought. Just quieter, expressed differently, scattered in gestures rather than tests. Even among humans, self-recognition doesn't appear all at once. Infants take time to realize the face in the mirror belongs to them. They play with it, touch it, smile at it like a stranger. But then one day, they reach for their own nose, guided by a dot seen only in the glass. And the world, for them, subtly shifts. Maybe for animals, that moment also comes, but in a context we haven't yet learned to recognize. Because minds are not mirrors of each other. They reflect differently. They bend light in unique ways. To understand the self of another species may require us to leave behind our own expectations, to listen in a different language, to see with different eyes. The mirror test was never really about mirrors. It was about asking who animals think they are, and whether they think at all. We now know they do. We see it in the way dolphins inspect themselves, in the way elephants linger before their reflections, in the way a magpie twists its head to examine a mark. We feel it in the gaze of a gorilla, calm and deliberate, meeting our eyes with something that feels uncannily familiar, not identical, but familiar. And in that moment of recognition between species, between minds, the mirror is no longer glass. It becomes something softer, a bridge, a question, a chance to glimpse ourselves not just in our own eyes, but in the minds of others. In a rainforest alive with echoes, a parrot calls out not just in sound, but in structure. Its cries rise and fall in distinct patterns, syllables, repetitions, pauses. Another bird answers, and together they engage in something more than noise. It is a dialogue, measured, deliberate, and remarkably specific. It might be easy to miss, but tucked within those sounds is a form of language, not quite human, not bound by grammar as we know it, but still layered with meaning, emotion, and intent. Across the world, animals are speaking. Some with voices we can barely hear, others with gestures so subtle they pass as coincidence. But as our tools improve, as we learn to listen beyond the limits of our own speech, we are discovering that language, or something very near it, is everywhere. Prairie dogs stand upright in the grass, chirping warnings that to our ears sound identical. But slow the recordings, chart the frequencies, and an astonishing truth unfolds. They aren't just saying danger, they're saying tall human in a blue shirt walking fast. Their calls describe predators by type, speed, even color, and they adjust based on who's listening, shifting urgency depending on the age and vulnerability of those nearby. These aren't instinctive yelps, they are information packets, compressed and encoded in pitch and rhythm. Whales sing in haunting loops that spiral through the ocean's dark corridors. Humpback males create long, elaborate songs that evolve over months. A song can travel from one ocean region to another, spreading like a cultural wave across thousands of miles. The structure matters phrases within themes, repeated with variation. It resembles music, but it also resembles something more, a shared language shaped not by biology alone, but by learning and transmission. Young whales mimic the songs of their elders, not genetically, but through immersion. Like children learning to speak, they rehearse, they refine. Vervet monkeys in Africa have distinct alarm calls for eagles, leopards, and snakes. But what's more striking is the response. When a vervet hears the eagle alarm, it looks up and runs for cover. The leopard call sends them up trees. The snake call makes them stand on two legs and scan the ground. The calls are not just labels, they are cues for action. The monkeys understand them as specific warnings, not just emotional outbursts. In the oceans, dolphins communicate with whistles so nuanced that researchers now believe they may use signature calls, name-like identifiers that refer to individuals. When separated, they call out one another's names and respond when their own is heard. These whistles are stable across time, not just mood-dependent, but enduring. They carry identity, and when combined with dolphins' abilities to mimic, gesture, and teach, a complex communication system begins to emerge, one that rivals our own in subtlety, if not in syntax. Honeybees return from foraging flights and perform dances on the hive walls. The angle of the dance indicates direction, the tempo encodes distance, and the vigor reflects quality. In darkness, surrounded by sisters, the dance becomes a map, and the hive listens. Octopuses, largely solitary, still use a strange visual language of shape and shade. Their skin pulses with patterns, waves of color signaling stress, curiosity, or calm. They flash white when startled, turn deep red when angry, and swirl with iridescent camouflage as they explore or hide. To watch an octopus communicate is to witness thought ripple across a body like liquid electricity. Even silence can speak. Wolves maintain social order with posture alone. A raised tail, a bared tooth, a lowered head. A glance becomes a paragraph. A stillness becomes a sentence. Within a pack, every gesture is read and responded to, holding the group together with invisible threads of shared understanding. And among elephants, communication travels through the ground. Low-frequency rumbles, too deep for human ears, vibrate through soil and stone, felt through the sensitive pads of their feet. These seismic messages can cross kilometers, allowing herds to coordinate from beyond sight, even beyond hearing. An elephant doesn't just listen. It feels the language in its bones. Humans, for a long time, thought of language as ours alone, our defining trait, our secret to civilization. But each new study, each carefully observed behavior, chips away at that illusion. Language is not one thing. It is many forms of connection, many ways to encode thought into action, intention into signal. It is sound and movement and color and vibration. It is passed through air, through water, through skin and space, and it is learned. Many of these systems are not fixed. Young songbirds raised in isolation sing broken tunes. Parrots invent new calls when introduced into unfamiliar flocks. Orcas in captivity develop their own dialects, distinct from any wild group. These shifts aren't random. They suggest creativity, culture, and an understanding that sound carries weight. We may never fully decode these languages. The words may be too fast, too foreign, too rooted in experience we can't share. But we are learning how to listen. We're building tools that reveal the layers we missed. Artificial intelligence now analyzes hours of animal recordings, uncovering patterns we could never parse by ear. What once sounded like static begins to resolve into structure. And slowly, wonderingly, we begin to glimpse the edges of vast, ancient conversations that were always happening, not beneath us, not beside us, but with us. In the shallow waters off the coast of Western Australia, a bottlenose dolphin swims with a sponge pressed tightly to her snout. She uses it like a glove, poking along the seafloor in search of hidden fish. It's a strange sight, unnatural at first glance, but this isn't a one-time trick. It's a tradition, passed down from mother to daughter. This peculiar behavior spans generations. Young dolphins watch, learn, and mimic. And before long, they too begin to wear sponges like inherited tools, as if knowledge itself had been handed down, not through DNA, but through demonstration. In the heart of West Africa, chimpanzees perform elaborate nut-cracking rituals using rocks as hammers and tree roots as anvils. They choose their tools carefully, carrying them long distances. And when the young ones reach the age of watching, they study every motion, the grip, the angle, the rhythm. It takes years to master. This isn't instinct, it's apprenticeship. Culture, long thought to be the province of humans alone, is now found in the forests, oceans, and plains in whispers of behavior passed from one mind to another. Not written, not spoken, but observed, practiced, and refined. Across species, across continents, animals are showing us that tradition is not always tied to language. Sometimes it's etched in movement, ritual, and place. In Japan, a troop of macaques once lived near a research station. Scientists provided sweet potatoes tossed into the sand. One young female, Emo, began washing her potatoes in the river. Soon, her playmates copied her, then their mothers. Eventually, nearly the whole troop adopted the practice, cleaning their food, even seasoning it by dipping it in salt water. When Emo died, the habit continued. Years later, it still does. A personal innovation became a cultural thread. In the sea, killer whale pods hunt in radically different styles, each shaped by location and tradition. Some beach themselves temporarily to snatch seals from the shore, a perilous tactic taught by elders. Others corral fish into tight bait balls, stunning them with tail slaps. A few even drop stingrays from heights to disable them. These are not genetic behaviors. They are regional customs, often learned through years of social immersion. Even their calls vary, forming dialects that are distinct to each pod. To be born into one group is to inherit not only a family, but a way of life. In the mountains of Taiwan, a population of Formosan rock macaques was seen using their tails to sweep away debris before sitting down. It wasn't universal, only certain groups did it. The sweeping wasn't about cleanliness. It was about comfort, about pattern, about familiarity passed on through mimicry. One generation teaching another how to exist. Culture, in its purest form, is memory embedded in behavior. It's not something coded into cells. It's something you watch, copy, and carry. Elephants, grieving at the bones of their dead, returning year after year to linger in silent circles. Meerkats, teaching pups how to disable scorpions, starting with dead ones, and gradually progressing to live prey. Crows dropping nuts onto roads for cars to crack, waiting for green lights before retrieving their prize. These are not random acts. They are learned, remembered, and sometimes even taught. In the forests of Uganda, chimpanzees use leaves as napkins to wipe their mouths or as sponges to sip water. Some fold them neatly, some chew them into pads. In one group, individuals perform a peculiar leaf clipping display, tearing leaves without eating them, a gesture with no clear purpose but one that spreads through the troop like a dance move, unique to that community. It might mean excitement. It might mean play. Whatever its meaning, it's shared, repeated, and inherited like an heirloom of sound and motion. Culture in animals is not always practical. Sometimes it's playful. Sometimes it's mysterious. In a sanctuary, an orangutan once taught herself to whistle. She did it often. And then, the others began to whistle too. There was no food reward, no functional gain, just a sound passed from lips to ears, a melody drifting from one being to the next. Tradition doesn't always come wrapped in ceremony. Sometimes, it's just a way of walking, a rhythm of grooming, a posture held when watching the stars. But it binds individuals together. It says, this is who we are. This is how we do things here. What's more, culture gives animals flexibility. It lets them adapt not just through evolution, which takes millennia, but through innovation, which can take days. It allows survival in a changing world by passing experience forward so that one individual's insight becomes the group's advantage. We are only beginning to map these traditions, to see how deeply culture roots itself in the wild. It doesn't look like our stories or songs, but it shares the same soul, memory, meaning, and belonging. It is a conversation across time, carried not in words, but in action. And it reminds us that we are not the only ones with heritage. We are not the only ones who teach. We are not the only ones who remember. In the quiet dark of the ocean, an octopus slips through a crevice no wider than a coin. It's not fleeing. It's exploring. It stretches one arm ahead, then another, tasting the world with suckers that can smell, touch, and taste at once. In its head, not truly a head, but a bulbous, soft mantle. A brain works without a skeleton, without a single bone to cage it. But that's only part of the story. 2/3 of its neurons live in its arms, giving each limb a kind of autonomy. It's a mind that is both central and decentralized. One that thinks not only with the brain, but with the body. And, still, it solves mazes, opens jars, remembers faces, escapes tanks in the night, and returns before dawn, leaving no trace but the absence of a crab. Octopus intelligence is strange, alien, and astonishing, but it is only one path the animal kingdom has taken toward cognition. Elsewhere, in a jungle canopy, a crow drops a nut into traffic and waits. The light turns red. The car passes. The nut cracks. The crow swoops down, grabs the reward, and flies off before the next vehicle arrives. Later, it fashions a hook from a twig, shaping it with deliberate movements to fish an insect from a crevice. It stashes food for the future. It watches others do the same and remembers where they hide it. It lies. It plans. It learns by watching. And it dreams, as shown in the way its brain patterns change during sleep, similar to mammals, despite taking flight on a lineage that diverged hundreds of millions of years ago. Crows are part of the corvid family, along with ravens, magpies, and jays. Their brains are small, but densely packed and shockingly efficient. Though their architecture differs from that of mammals, their abilities echo ours in eerie ways. They recognize themselves in mirrors. They mourn their dead. And they teach us that size is not always the measure of intelligence. Elephants remember routes to water they haven't visited in years. They coordinate across vast distances using infrasonic rumbles that travel underground. They comfort one another in grief, reaching their trunks toward the fallen. They pause at bones with reverence, gently tracing tusks that no longer move. And when reunited with a friend after decades, they trumpet with unmistakable joy. Their brains, among the largest in the animal kingdom, support layered memories and rich emotional lives that stretch across space and time. In the sky, pigeons return home across entire continents, guided not by sight alone, but by an innate ability to read the Earth's magnetic field, a compass etched into the mind, as if geography were a sense. Honeybees, no larger than a fingernail, navigate complex environments, vote on new homes, and relay directions through dance. Their hives function as collective minds, distributed intelligence operating through thousands of coordinated parts. Even insects, once thought to be purely mechanical, now show glimmers of cognition. Ants teach one another by tandem running, a process where a knowledgeable ant slows down to guide a follower. Bees can learn to solve puzzles for rewards, even when it means pushing tiny balls into precise positions. They exhibit optimism and hesitation. They show signs of emotion. And then there are mammals, our closest relatives, but also our mirrors. Dolphins give each other names and answer to them. They invent games and remember allies. They coordinate during hunts and assist the injured. Some have even been observed collaborating with humans, herding fish toward waiting nets in exchange for a share. Their intelligence is not merely social, it is layered with nuance, with agency, with choice. Great apes build tools, deceive rivals, learn human gestures, and sometimes even communicate using symbol boards or sign language. In controlled settings, they show curiosity, humor, frustration, and even guilt. They fail and try again. They improvise. They share food without being asked. When a bonobo sees a stranger in need, it often helps without any reward in sight. The roots of empathy are deep and wide. But cognition doesn't always come from complex nervous systems. Consider the jumping spider, tiny, with fewer than 1 million neurons, yet capable of planning elaborate routes to reach prey. When faced with an obstacle, it climbs to a vantage point, scans its options, then chooses the most efficient path, even if it means losing sight of the target. It sees in color. It remembers what works. It hunts not by instinct alone, but by strategy. What these examples show is not a hierarchy of minds, but a web, a rich tangle of cognition that has emerged through countless pathways. Intelligence is not a single thread running through the tree of life. It is a forest of solutions, each shaped by the needs of the species, each adapted to its own world. Some animals think in maps, others in sound, in scent, in vibration, or in movement. Some remember the past to prepare for the future. Some learn by doing, others by watching. Some teach, some lie, some play, some grieve. And yet, across all this variation, there are echoes, patterns that suggest convergent minds evolving in distant bodies. A dolphin and a crow, a bee and a chimpanzee, a cephalopod and a child. Their nervous systems may differ, but the spark of cognition burns through them all. It forces us to ask, what does it mean to be intelligent, to be aware, to know? Perhaps the answer isn't found by measuring animals against ourselves, but by meeting each mind where it lives in its own element, on its own terms, in water, in air, in silence, in song. To understand the minds of animals is to widen our own, to step beyond our species, our syntax, our sense of supremacy, and in doing so, to find a more generous definition of consciousness, one that reaches across wings, fur, scales, and skin, and recognizes that thinking has always worn many shapes. We are not alone in our minds. We never were. In the arid reaches of the Kalahari, a meerkat freezes on its hind legs. Its eyes scan the horizon, while the rest of the clan forages beneath the sand, trusting this sentry to spot danger before it strikes. For hours it might stand, unmoving, exposed, resisting every twitch of instinct that urges it to run, to eat, to rest. This is not reflex, it is restraint. A simple creature, by appearance, holding the tension of patience like a string pulled taut between survival and sacrifice. Across the globe, in a lab shaded from natural light, a crow waits beside a vending tube. At its feet, a tempting piece of food lies just out of reach. It could eat now, snap up the lesser prize and be done. But the bird looks to the device, and then to a small tool, a hooked stick it learned to use in earlier trials. It picks up the tool, slots it into the machine, and retrieves a better reward, not just because it knows how, but because it understands the wait is worth it. It resists immediacy. It trades now for later. This ability to delay gratification is not as common in the animal world as raw instinct might suggest. But when it appears, it offers a glimpse of something deeper, the presence of planning, of mental time travel, of a mind that can imagine what it does not yet have and hold that image long enough to guide behavior. In the forests of Japan, capuchin monkeys hoard stones not for defense or comfort, but to use as tools for cracking nuts. Some even select stones based on weight and balance. They keep them, carry them, and return to their stash days or even weeks later. These monkeys aren't just reacting, they're preparing, they're investing in a future need. Scrub jays, small and unassuming, bury food in scattered caches. But what's extraordinary isn't the act of hiding, It's the complexity with which they manage their storage. They remember which foods spoil first and retrieve them accordingly. They take note of who might be watching and re-hide items when unobserved, suggesting a theory of mind layered with caution. They even plan for hunger they don't yet feel. In controlled studies, jays fed one type of food in the morning and another in the evening learned to cache the food they wouldn't get the next day, essentially packing breakfast in advance. That level of planning edges close to what we might call foresight. In the savannas of Kenya, elephants navigate toward watering holes that haven't been visited in years, adjusting their pace to arrive precisely when the rains return. Matriarchs remember ancient routes, seasonal patterns encoded not in maps, but in memory passed from elder to young. And during droughts, they ration their movement, conserving energy, choosing shaded paths, delaying their search for food in favor of finding water first. These decisions are not random. They're measured against knowledge the animal holds about a world it has yet to step into. Even among insects, the seeds of patience exist. Digger wasps, before laying eggs, construct elaborate burrows, complete with multiple chambers. They then paralyze prey and place one per chamber, sealing each with precision, ensuring their young will awaken to a fully stocked pantry. The mother wasp will never meet her offspring, but still, she prepares. She anticipates needs that are not her own. Delaying gratification, at its core, is an act of imagination. It means sacrificing something tangible, warmth, food, ease, for the sake of something still theoretical. In humans, it's called executive function. In animals, it appears in flashes. A chimpanzee refusing a grape today for a banana tomorrow. A dog resisting a treat when told to stay. An octopus sitting still, tentacles hovering, until the crab gets close enough to strike. But planning isn't just about waiting. It's about ordering time. When New Caledonian crows are given a selection of tools, only one of which will be useful later, they consistently pick the right one and set it aside. Hours later, when the need arises, they retrieve it. This isn't instinct. It's choice informed by memory and motivated by imagined consequence. Among orangutans, males will sometimes make long calls, deep vocalizations that echo through the jungle, not because they're in danger, but to announce where they'll travel the next day. Females and other males adjust their routes accordingly. It's not just communication, it's scheduling. And within our own homes, pet dogs and cats often learn patterns too. They know when the food will come, when the door will open, when your steps mean play, and when they mean goodbye. Some will even try to preempt you, bringing a leash, waiting by a bowl, or pacing by a window minutes before your return. They live in the present, yes, but they sense the rhythm of time and plan for its beats. What all of this suggests is not just cleverness, but control. The ability to hold still in a world that rewards motion, to choose future comfort over immediate gain, to see tomorrow as something real enough to act upon today. This capacity likely evolved not in comfort, but in hardship, in places where food is rare, danger is high, and energy is precious. For such species, patience becomes survival. It's a tool as sharp as any tooth or claw, and perhaps that's the most surprising truth of all. That in the wild, where life seems ruled by urgency and instinct, some of the greatest strengths come not from speed, but from stillness. Not from hunger, but from waiting. Not from what an animal does now, but from what it chooses not to do. In the damp underworld of a forest floor, something moves. It doesn't slither, or crawl, or fly. It spreads, like a thought without a skull. A bright yellow smear of living matter, creeping almost invisibly slow, and yet undeniably alive. This is Physarum polycephalum, a slime mold and a mystically present organism with no brain, no nerves, and no central control. And yet, when presented with a maze, it can solve it. It will stretch tendrils down multiple paths, retracting from dead ends and reinforcing the shortest route to food. It remembers where it's been, avoids repeating mistakes, and adapts to changes in its environment with a grace that should not be possible in something so simple. It's hard to call it thinking, and yet it isn't mindless. The slime mold perceives, decides, and responds. It demonstrates a kind of memory, not stored in neurons, but in the patterns of its own body. If a path was once traveled, its surface chemistry changes, leaving behind a molecular trace like a whispered reminder. It has no eyes, no ears, no brain, yet it maps the world and makes choices, and it's not alone. In the drifting blue belly of the ocean, jellyfish pulse through the currents like ghosts with heartbeat rhythms. Their bodies are gelatinous bells with trailing arms and stinging filaments, and for most species, there is no central brain at all. Instead, a loose network of nerves encircles the body, responding to touch, light, gravity. It's enough to let them swim, to hunt, to glow in the dark, to navigate vertical layers of water depending on the time of day. Some even show sleep-like patterns, rising and falling into cycles of stillness, resetting themselves after rest. This decentralized intelligence is less like a spotlight and more like a constellation. It doesn't beam sharply in one direction. It flickers gently across the body, scattered and responsive. The box jellyfish, with its 24 eyes and strange, cube-shaped form, is even more remarkable. Despite lacking a brain, it has vision with lenses, retinas, and the ability to track objects and avoid obstacles, making it one of the only known creatures without a brain to demonstrate complex visual behavior. And deep in coral reefs, sea stars glide on hundreds of tiny tube feet, controlled by a nerve ring that circles their central disk. If a starfish loses an arm, it doesn't just survive, it remembers. In some species, an arm torn from the body can regrow into an entirely new individual, and it continues to respond to the world around it while the regeneration takes place. What, then, is the center of such a mind? We often imagine intelligence as something enclosed, a brain in a skull, wires in a circuit, but many creatures show us another path. A mind can be smeared across a body. It can live in a pattern, not a point. Octopuses, while possessing a central brain, operate largely from their arms. Each limb has its own network of neurons, capable of independent movement, sensation, even problem-solving. Their arms can open jars, manipulate tools, and explore new textures without direct instruction from the brain. It's as if each limb is a semi-autonomous agent, all coordinating through a fluid conversation of chemical signals and tactile feedback. And then, there are sponges, the oldest and simplest of animals who lack nerves altogether. They do not move quickly or respond with speed, but they process their environment nonetheless. Their cells coordinate to regulate water flow, filter food, and react to changing conditions. They communicate through calcium waves and electrical pulses, hints of a pre-nervous intelligence that may have shaped the evolution of minds to come. Even plants, though not animals, whisper a similar secret. Root tips sense gravity and moisture. Leaves adjust their angle to maximize light. Trees in a forest warn each other of danger through underground fungal networks, altering their chemistry in response to a neighbor's stress. Though they do not have brains, they too appear to weigh options, react to memory, and make decisions shaped by history and need. All of these systems challenge our idea of what a mind must be. They suggest that thinking may not require a brain at all, that coordination, decision, even the faint outlines of memory, can emerge from networks, fluid, flexible, distributed. What does it mean to make a choice without a self? To solve a puzzle without a consciousness? In slime molds, in sea stars, in jellyfish and plants, we see systems that compute without computing as we know it. They solve problems not through logic, but through interaction with their environment. The shape of the space becomes part of the mind. The terrain itself is folded into the decision, and in doing so, these creatures blur the boundary between body and brain. This kind of intelligence is older than us. It is older than vertebrates, older than bones, older than thought shaped by language. It belongs to the deep time of Earth, when life was still finding ways to feel its way forward in a world of rock and sea. And yet, even in these ancient forms, we find the same shimmering spark, a capacity to sense, to react, to persist, a quiet logic that doesn't need neurons to shape intention. Perhaps intelligence is not rare, or delicate, or uniquely ours. Perhaps it is a property of life itself, a spectrum of awareness that runs from the softest ripple of a jellyfish to the loudest thought in a primate brain. Not all minds wear faces, not all memories sit in skulls, but they remember, all the same. In the quiet hours of night, when the world softens and thoughts begin to slow, many of us turn inward. We close our eyes, and a different kind of life begins. In sleep, our minds unfurl into dreams, strange narratives that flicker like old film reels behind our eyelids. But we are not alone in this hidden theater. In homes, forests, oceans, and burrows, animals sleep too. And while they rest, something stirs within them. Tiny paws twitch, eyes dart beneath closed lids, wings flutter in stillness. These silent movements are whispers from a world that exists only in dreams. Dogs are among the most familiar guides into this realm. Watch a sleeping puppy, and you'll see the story unfold. First comes the gentle rise and fall of breath. Then a paw paddles midair, a tail flicks, a soft whimper escapes. The eyes, though shut, begin to dance rapidly, a sign of REM sleep, the stage where most vivid dreams occur. Neuroscientists believe that in these moments, dogs may be reliving their day, chasing a ball, sniffing a trail, curled beside someone they love. Their sleeping minds replay life in fragments, stitching together memory and motion into a narrative only they can experience. Rats, too, have shown signs of dreamlike reactivation. In carefully controlled lab experiments, researchers trained them to run through mazes while recording activity in the hippocampus, the brain's memory center. Then, as the rats slept, those same neuronal patterns echoed again. It was as if their minds were retracing the route, step by step, in a rehearsal made not for survival, but for understanding. The brain, even at rest, was still solving, still remembering, still wandering. Birds add a new twist to this tale. Songbirds, for instance, don't just dream, they may rehearse their songs in sleep. Zebra finches, known for their melodic calls, display brain activity during slumber that mirrors the precise structure of their waking tunes. Juvenile birds, still learning the song of their species, appear to strengthen their musical memory overnight. Sleep is not idle. It is practice. It is polishing. But perhaps the most hauntingly beautiful example comes from beneath the sea. In coral reefs and ocean caves, the octopus rests in colors that shift like thought itself. In a dim tank, a researcher filmed an octopus curled in sleep. At first, she was pale and still. Then suddenly her skin darkened. Patterns rippled across her body, from speckles to stripes to sudden flares. Camouflage changed in pulses, as if reacting to unseen prey or lurking predators. And yet she remained motionless, eyes closed, surrounded by silence. Was she dreaming? Octopuses have complex nervous systems with more neurons in their arms than in their brains. They learn, explore, and solve problems with an intelligence that surprises even seasoned scientists. And though we can't ask them what they see in their dreams, their behavior suggests a kind of internal life that does not sleep when the body does. Even reptiles, once thought to lack REM sleep entirely, have begun to show signs of it. Bearded dragons, when observed in darkened labs, shift through cycles of brain activity that mirror REM and non-REM states. Their sleep, though different from ours, seems to carry a rhythm, a back-and-forth wave between quiet rest and something more animated. Cuttlefish, relatives of the octopus, display a similar pattern. In the midst of stillness, their skin blooms with patterns they once used while hunting or courting. These flashes occur in sequences, hinting at mental replay or perhaps imagination. Scientists hesitate to call it dreaming, but what else can we call a rehearsal of the self in sleep? The science of animal sleep is still young. Some creatures, like dolphins, sleep with only half their brain at a time, one hemisphere staying alert while the other sinks into rest. It's a survival trick, allowing them to surface for air and scan for threats even while asleep. Yet even they show periods of restful disengagement that resemble dreaming in other species. Parrots, too, appear to experience REM sleep, their vivid feathers gently rustling in the dark as they perch with heads tucked under wings. Not all dreams are shaped by sight. For animals that live in darkness or rely on other senses, dreams may play out in textures, sounds, or smells. A mole rat's mind might echo with tunnels. A bat's dream might shimmer with echoes. And what of elephants, those giants of memory? In their slumber, lying down only when safe and at ease, do they relive long journeys? The birth of a calf? The scent of a watering hole they haven't visited in years? We don't know. But their slow, deliberate dreams, if they exist, must be immense. Across the animal kingdom, sleep is not simply absence, it is restoration. It is the quiet stage upon which memories are reassembled, patterns reinforced, and perhaps new possibilities imagined. Dreaming may be one of the oldest forms of storytelling, an internal tale told by the mind to itself, a rehearsal for tomorrow drawn from the lessons of yesterday. When we close our eyes at night, we enter a space not wholly our own. We join a vast, shared tradition, one that hums in dens, in nests, in oceans and trees, a world where dogs chase dreams instead of rabbits, where birds sing silently to themselves and octopuses shift color in rhythms only they can know. Perhaps, in the quiet hours of sleep, We are all just animals remembering who we are. In a quiet research center nestled in Austria's rolling countryside, two capuchin monkeys sit side by side in their enclosures. A scientist approaches with a tray, offering each monkey a small task. Hand over a token, receive a treat. Both comply. The first monkey receives a crisp slice of cucumber. The second, a juicy grape, richer, sweeter, undeniably better. The first monkey watches this transaction closely. Then, when she's asked to repeat the task, she does. But when handed another slice of cucumber, she hurls it back at the scientist with a sharp bark of protest. She rattles the cage bars, slaps the ground, and refuses to participate. It looks like a tantrum, but it's more than that. It's a response to unfairness. In humans, this reaction has a name: inequity, aversion. It's a fundamental sense that rewards should match effort, that value should be distributed fairly. And while it once seemed to belong only to our species, science has begun to find echoes of it elsewhere, in fur, in feather, in tusk. Chimpanzees are among the clearest examples. In carefully designed studies, they don't. Just notice when they're shortchanged, they remember. When paired with a partner receiving higher value rewards for the same task, chimps show reluctance to continue. Some sulk, others demand better compensation, or refuse to cooperate altogether. The expectation isn't just for more, it's for balance. If both partners receive the same lesser reward, even if it's not the preferred option, the apes tend to tolerate it. But when the scales tip in favor of another unjustly, something inside them protests. This behavior doesn't require language. It doesn't require law. It requires only a sense of relative value and a willingness to respond when that value skews. Dogs, too, appear to carry this instinct. In experiments, they're asked to offer a paw on command, first for a treat, then for nothing. When two dogs are tested side by side, and one continues to be rewarded while the other is ignored, the unrewarded dog will often stop cooperating. It will avert its gaze, look to the handler, then to the rewarded dog, and finally refuse the task. The breach is not in the task itself, but in the asymmetry of return. These aren't random responses. They are emotional calculations. But fairness isn't only about personal benefit. In more complex social animals, the idea of justice extends beyond the self. Elephants have been observed intervening when younger members are bullied within the herd. They mediate conflicts, step between aggressors, and offer comfort to the distressed. In one instance, a dominant female was seen punishing an adolescent, not for harming her, but for harassing a smaller calf. The correction wasn't selfish, it was communal. This sense of moral structure, of upholding group stability, may be older than we think. In bonobo communities, our gentler primate cousins, social harmony is enforced through grooming, reconciliation, and subtle displays of coalition. When fights break out, others often step in not to escalate, but to de-escalate. Peacemaking is part of the social fabric, and those who consistently behave unfairly, hoarding food, for example, or showing aggression without cause, tend to be marginalized by the group. They lose social standing. They are not trusted. It is not punishment in the way we define it, but it is consequence, shaped by the collective. Crows, too, remember those who cheat or deceive. In experiments, birds who were shortchanged by researchers given less food than expected, or tricked in some way, were later less cooperative, and even spread alarm calls about the individual. They hold grudges, and those grudges can spread through their social network. These reactions are not the product of abstract reasoning. They are rooted in emotion, frustration, disappointment, perhaps even anger. But underneath, there is a system, a structure that says, if I give, I should receive. If I play fair, you should too. And if not, I will remember. But fairness is not always symmetrical. Among vampire bats, which live in tight-knit roosts, fairness takes the form of reciprocal sharing. Bats that fail to feed during the night are often regurgitated blood meals by their roost mates. But this charity is tracked. Bats are more likely to share with those who've shared with them before. And if a bat repeatedly takes without giving, others begin to ignore its needs. It's not just kindness, it's reputation. Trust becomes a kind of currency. Even in fish, patterns of social enforcement appear. Cleaner wrasses, tiny reef dwellers that nibble parasites from larger fish, operate in mutualistic partnerships. If a cleaner fish cheats by taking a bite of healthy tissue, the client fish may leave, or even punish the offender. Other fish watch these interactions, learn from them, and choose partners based on observed fairness. The reef becomes a marketplace of reputation, policed not by force, but by memory and choice. What all of this suggests is that fairness is not merely a human invention. It is an adaptation, one born of social living. In groups where cooperation matters, balance matters too. And where there is balance, there must be a mechanism to detect and respond to imbalance. We tend to imagine morality as something taught etched into us by stories, religion, rules. But long before we built civilizations, before we could write laws or weigh scales, the seeds of justice were already taking root in the minds of other creatures. Not every animal demands fairness, but those who live in tight societies who rely on each other for food, for care, for protection, seem to carry within them a quiet expectation that work will be met with reward. That generosity will not be exploited. That the group matters more when all are treated with care. And when those expectations are broken, they speak if not in words, then in refusal, resistance, and remembrance. In a world shaped by survival, the sense of justice may be one of the most fragile and powerful traits of all. It says, I see what is given, I know what is fair, and I remember who breaks the balance. In the unseen language of the animal world, emotion travels quietly, not through facial expressions or dramatic gestures, but through molecules in the air, vibrations in the ground, whispers in pitch we cannot hear. Where we often rely on sight to detect a mood, a furrowed brow, a downturned mouth, many animals sense emotion without ever looking. They read the world through scent and sound, tracing invisible trails of feeling left behind like fingerprints. A mother mouse separated from her pups emits a cry too high for us to hear. It is a sound of longing, of urgency, encoded in ultrasonic waves. Her pups, still hairless and blind, respond by calling back. Their own tiny distress signals pierce the quiet in bursts, and she follows them like a beacon. There is no learning involved. This is instinct layered with attachment, emotion mapped directly into frequency, vibration, and tone. Elephants speak in seismic whispers. Through deep, low-frequency rumbles, they communicate across miles. These infrasound calls roll through the ground like thunder, reaching the feet of distant herds. Elephants detect them through sensitive cells in their feet and trunks, reading the emotional state of others from a distance. A panicked call vibrates differently than a greeting. A mourning mother sounds nothing like a migrating bull. Even before seeing one another, they feel each other's presence. And it's not just kin they respond to. When an elephant encounters the bones of a fallen relative decades after death, stripped clean by time they linger, they touch the skull gently with their trunks, trace the worn tusks, pause in stillness. Some even return again and again to the same site. What draws them back is not just memory, but something more physical, perhaps a lingering chemical signature, a scent left in the porous ivory that still carries a trace of who was lost. In the elephant's world, grief does not always need a face. Sometimes, it only needs a shape, a smell, and the absence of sound. Dogs are perhaps the most familiar empaths in our lives, and yet we often underestimate how they know what they know. When you're sad, a dog may press their head into your lap or curl beside you without prompting. But what guides that comfort? Studies suggest dogs can smell stress. The chemical changes in our breath, sweat, and skin create a shifting cloud around us. Subtle to humans, but rich in information to a dog's nose. They can detect fear, depression, even illness, long before we're aware of the symptoms ourselves. Their empathy is olfactory, anchored not in what they see, but what they smell. In prairie voles, small and unassuming rodents known for their lifelong monogamy, empathy reveals itself through behavior. When one vole is stressed, their partner mirrors that stress. Their heart rate changes. Their cortisol levels rise. And if they're allowed to approach, they perform acts of grooming, not random, but directed toward soothing. Scientists have recorded this response time and again. The voles seem to feel what their partners feel, not out of habit or training, but through chemical cues that signal distress. Emotion is contagious, passed silently between them. Whales, with brains shaped by millions of years of social living, offer a haunting form of acoustic empathy. Their songs travel for hundreds of miles underwater, shifting in pitch and structure depending on mood, season, and circumstance. When a pod member is injured or isolated, others may gather, circling and singing low, mournful tones that fall into rhythm together. These songs are not cries for help. They are acknowledgments of presence, of pain, of shared experience. Grief, in the ocean, is a chorus. Even insects, long dismissed as simple or unfeeling, have begun to challenge our assumptions. In honeybee hives, stress can ripple through the colony without a single bee needing to see another. When one bee encounters a threat, a predator, a rough handler, an unexpected danger, it releases an alarm pheromone. This scent doesn't just signal danger, it alters the behavior of the group. Bees become more alert, more defensive, even if they haven't seen the cause of the alarm. Emotion, for them, is chemical, a shift in the hive's atmosphere that changes everything. Pigs, intelligent and emotionally complex, also respond to the distress of others. In group settings, when one piglet squeals in fear, the others often react not just by fleeing, but by approaching and touching the distressed individual. In some experiments, pigs trained to anticipate treats became visibly upset when a partner pig was denied the same reward. Their empathy isn't theoretical. It's physiological, mirrored in heart rates, movement, and vocal tones that change with the emotional state of those around them. And then there are cows, often overlooked, yet deeply attuned to the emotional weather of their herd. A cow separated from her calf will vocalize at a different pitch than usual, longer, lower, more urgent. Other cows respond to this change with increased alertness, even agitation. When a familiar cow is removed, the group dynamic shifts, grazing slows, eyes scan more often. There is a kind of collective awareness that something is missing. These forms of empathy challenge what it means to feel with another. They do not always involve conscious sympathy or complex thought. Instead, they unfold through systems tuned to the smallest changes in sound and scent systems that have evolved not just to detect danger, but to maintain connection. In social animals, survival often depends on the group, and the group survives best when its members can feel each other's needs without needing to explain them. We live in a visual culture, but nature reminds us that emotion is not always seen. Sometimes it is breathed in. Sometimes it is heard in vibrations too deep for our ears, or carried on the air in particles too faint for our nose. Sometimes it is simply known. To the animals who navigate their world through scent and sound, empathy is not an abstract virtue. It is a biological reality woven into the way they live, the way they bond, the way they care. In this quiet language, emotion becomes environment, and in that environment, connection is everywhere. At some point in childhood, many of us were taught a kind of quiet hierarchy. Humans on top, animals below. We build cities, we write books, we speak in poetry, and fly to the moon. Animals, we were told, operate on instinct alone, driven by hunger, fear, reproduction. Their minds, if they existed at all, were considered rudimentary, mirrors that did not reflect, eyes that saw but did not contemplate, voices that cried out but did not mean. And yet, across the slow decades of research, of watching and waiting, of asking different questions in different ways, that story has begun to change. We now know that animals plan, they play, they deceive, they love, they remember, they grieve. We've watched elephants mourn their dead with gentle touches of the trunk, and dolphins carry the bodies of calves for days, reluctant to let go. We've seen octopuses solve puzzles with the ease of bored students, and parrots invent new words to tease their keepers. Whales sing across oceans, bees dance in coded directions. Apes teach traditions that last beyond a single lifetime. The gap between us and them is not a wall. It is a thread, sometimes stretched thin, sometimes tangled, but never truly severed. And at the center of this thread is consciousness. Not the philosophical abstraction, but something simpler and more direct. Awareness. Noticing the self, noticing others, reacting not only to stimuli, but to meaning. When a crow hides its food only to move it again after being watched, we are seeing strategy. When a dog comforts a crying human with no command, we are seeing compassion. When a chimpanzee uses a mirror to inspect a wound on her body, we are seeing a mind looking inward. These are not the exclusive gifts of humanity. They are seeds scattered throughout the tree of life, blooming in strange and wondrous ways. Some animals may not pass our tests of intelligence, not because they lack thought, but because they live in minds so different from our own. A bat, navigating the night with sonar, hears in dimensions we do not. A mantis shrimp sees colors we cannot even imagine. A turtle migrates across entire oceans with no map, no compass, just an ancient sense of home drawn in magnetic lines. Their worlds are not less rich than ours, just alien, just other. And in their otherness lies an uncomfortable truth. Intelligence is not one path, but many. We've often defined thinking by what mirrors our own: language, logic, tools. But what if we expanded that definition? What if empathy could be a sign of intellect? What if culture didn't require cities, but could be found in the way a bird sings its regional dialect, or the way an orca teaches her calf to hunt? What if art could be recognized in the elaborate sculptures of a bowerbird or the hypnotic displays of a cuttlefish? What if fairness, morality, and even a sense of justice weren't born with us, but shared emerging wherever life grows complex enough to need it? The more we look, the more these questions take shape, and the more they shape us in return. Because rethinking the animal mind forces us to rethink our own. It softens the sharp edge of human exceptionalism and replaces it with something more humble, more curious. It reminds us that we are not the center of the story, but a part of it. Another species trying to make sense of the world, navigating relationships, solving problems, searching for meaning in the darkness. It calls us to pay closer attention not just to the brilliance of others, but to our impact on them. If an elephant can remember kindness for decades, what does it mean to break its trust? If a whale mourns, what does it mean to silence its song with sonar and steel? If a pig forms bonds and feels loss, what does it mean to treat its life as disposable? Recognition is not a passive act. It carries weight. To acknowledge another mind is to accept responsibility for how we treat it. And perhaps this is the deeper meaning behind all these discoveries, not simply that animals are smarter or more emotional or more complex than we assumed, but that they were never ours to define in the first place. They were whole all along. We were simply not listening, but now we are. And the more we listen, the more we begin to hear not just their voices, but something ancient within ourselves, a shared inheritance, a resonance. The understanding that consciousness did not arrive fully formed in a single species, but unfolded slowly, like light breaking through fog, glimpsed in the song of a bird, the play of a dolphin, the quiet gaze of a cat sitting beside you without needing to speak. We are not alone in our wonder, not alone in our fear, not alone in our need to be seen, understood, remembered. Somewhere in a forest, a crow cracks a nut with a passing car. Somewhere in the ocean, an octopus builds a fortress of shells. Somewhere in the sky, a parrot calls out a word it learned years ago, long after the one who taught it has gone. These are not accidents of behavior. They are stories, lives unfolding. And as we begin to recognize them, not just as instincts, but as choices, as perspectives, as minds, something shifts. The line between human and animal does not vanish, but it blurs. And in that blur, there is space. Space for reverence, space for humility, space for a quieter kind of wisdom that doesn't come from proving our superiority, but from honoring the extraordinary diversity of minds that share this world with us. We've stared into mirrors for so long, searching only for ourselves. Now, perhaps, it is time to look out the window.